And we're back with another captivating physics problem, so it's time to sort it out. This is friction to projectile. In this we have a table, we have a box, and we have to consider friction. It has an initial speed, we know its mass, we know the distance it travels before it leaves the table, and we know the coefficient of friction on the table. We want to know the launch speed, how long it will spend in the air, and the horizontal distance from the table that it will land. Start by doing a free body diagram for this. We can see that forces are balanced in the y direction. We have one force in the direction which is left that will oppose the initial velocity. The box is already sliding, so we're going to call that force of friction kinetic. Then let's write an expression for the net force. It is just the force of friction, and that would be given by the coefficient of kinetic friction times the normal force. We're on a level surface, so the normal force is equal to mg. Notice that mass is on the top and the bottom of the expression, so we can cancel that out. And the acceleration here would be given by mu sub k multiplied by little g. Then let's put that in a kinematics formula. We want to know the final velocity after undergoing some acceleration, but we do not know the time currently, so this is the formula that we would like to use for that. Then plug in for the acceleration. Remember to make that negative because the initial velocity is positive. That means the acceleration has to be in the negative direction. Then sub in, rearrange, and we can arrive at an expression like this for the final velocity before it leaves the table. Then it becomes a traditional projectiles problem where it's launched horizontally, in other words at an angle of 0. So that means that the time in air can be given by this expression. Rearrange that for the time. Then if we found the final velocity leaving the table above, that's what we'll use in the x direction. Delta x would be given by that velocity with which it leaves the table, multiplied by the time in air, which we found above. So I hope that turns your screens green.